السلام عليكم. الصوت واضح؟ طيب ممتاز. Good. طيب, do we have non-Arabic speakers in this session today? Okay, good, Mohammed. I will start recording the class. You give me, please, a few seconds. Okay, so today, inshallah, we are going to proceed from this point. Actually, this is the second part of meeting 2. This is the second part of meeting 2. I have already posted the first part of meeting 1 on LMS. I hope you could download it. Now we will proceed from this point, which will talk about the complexity of the code of the algorithms. Now, before we start, I think okay, I think some students, they have problem with the sound. Just not to interrupt the meeting. If anybody has any problem from your colleagues, just please one of you reply him to leave the meeting and log in again. طيب, so we started in the previous class. I would like to go back one slide. We talk about the how to examine and analyze the performance of the algorithms, and we said that we cannot rely on the time analysis because the time may vary from one machine to another. يعني احنا بصير في اختلاف التايم, ما بنقدر ان نعتمد على التايم فقط في حساب كفاءة وفاعلية الالجوريثم. السبب انه التايم دائما بيكون مرتبط بعدة عوامل اخرى, منها سرعة الرام, الكباسيتي للرام, سرعة السي بي يو. So instead of analyzing the algorithm based on the time, we need to analyze it based on the complexity. So before we start analyzing the algorithm based on the complexity, we would like to go through the process of structuring the algorithm. So we have two types of presentation or structures for algorithms. We can either represent the algorithm using flowchart, as you can see in this diagram, or we can write the code using pseudocode. And this is an English syntax. We can use simple English statements to describe the code and the functions. So we have two ways to consider while writing the code and preparing the algorithm. So either we use the flowchart or we use the pseudocode. For programming purposes, and at the end of the design of any algorithm, you need to send this algorithm for a developer in order to write the proper code in one of the programming languages, whether it's Java or C++ or Python. So for easier understanding by the developer, it is must prefer to use the pseudocode. So pseudocode is much clearer for the developer to read the code and implement it. So it's a high-level description of the algorithm. Okay, it's very clear because we are using English language. It doesn't require much space. See what's about the space here that the flowchart is taking, and see the space here that the pseudocode is taking. And we don't take care too much about the details. See, for example, input hours. we don't mention whether the hours is integer or string or whatever. It's very abstract. So we are hiding the details of the design. Now the complexity of any algorithm is measured by something we call it big O notation. Big O notation. We have three types of notations. We have big O, omega O, big O, big omega, and theta. O, omega, theta. We have three types of notations we are going to consider in our analysis. I'll go through it, inshallah, in more details. Now, what do you mean by the complexity? Let's say you have two functions, function fn and function gn. We say that the function fn is O of gn if there are positive constants c and nc, or sorry, n0, such that gn multiplied by the constant c is greater than fn for all values of n greater than n0. What does this mean? It means that the growth of the complexity of gn is much bigger or equal to fn. So gn is always bigger than fn when it is multiplied by c constant for all values n that are greater than n0. So here in this example, you see that fn is, this is the dark black one. This is the fn, the black line. And you can see here at this point, starting from n0 and bigger number, yani more than n0, now cgn start to grow up more. So gn is growing more than fn. So that's called fn is O gn, means the growing of fn is less than the growing of gn. This is an example. If you have a function which takes 2n plus 10, okay, later we will go in more details on how to find the 2n plus 10. Now just consider the example at this level. So 2n plus 10, here in this example we have the 2 and we have the 10. These are constant. Okay, fixed number. هاي أرقام ثابتة ما بنهتم فيها. We just take care of the variable, and the variable here is n. So the whole function is O of n. We don't consider for the big O notation the constant. We don't say the function is O 2n plus 10. We don't care about the constant here. Right. So if we say fn is O of gn, means the growth rate of gn is bigger than the growth rate of fn. So that means gn grows more fn, right? But gn is not less than fn, because this statement is incorrect. So gn grows more only in this case, fn grows more only in this case, and the same growth in both cases if both of fn and gn are equal. Because remember here we see here in this example, we see that gn is greater than or equal, which means at some point they might have the same growth rate. So we might come to a point where both of gn and fn have the same growth rate. When gn equal fn. And at this state, actually, this is the case where fn equal gn, when both of them at point n0. The other notations that we have is the big omega and big theta. Big omega and big theta. So for Fn is omega of Gn if there is a constant C is greater than 0, which means positive, and the constant N0 is greater than or equal to 1, which is also positive, such that Fn is greater than Gn. Greater than Gn. But theta, and by the way, I will go in more details about omega and theta. In theta, it is actually the average case. So here, Fn is less than Gn or equal Gn and greater than or equal Gn. What does this mean? Yani, what do we mean by saying this? What is the value of x in this example? X is greater or equal to 5, and at the same time x is less or equal 5. What does this mean? Exactly. Yes. يعني بحكي الاكس هي اكبر او يساوي 5 وبنفس الوقت اقل او يساوي 5 معناته هي 5. That's true. That is the theta. I will make it very easy for you. I know that it might be complicated now, but I will make it much easier for you to know the difference between big O, big omega, big theta. So in big O, have you how many students have finished the M180? Okay, good. Excellent. طيب. Let me give you a clue. What do we mean by big O, big omega? Okay. Let me give you a clue. See, each algorithm, in order to find the complexity, we have to go through the code of the algorithm line by line. Okay, Lama, no problem. Let me give you a clue, even if it's not 100% clear for all of you. When I go in more details in later classes, you will know what I mean. See, each algorithm, in order to be analyzed, we need to go through the code of the algorithm line by line. And we find the complexity of each line in the code. Some line of the code are executed one time. For example, when I say integer x, this line of code will be executed at constant time because it's going to be executed only one time. So the time that this line is taking is actually 1. But when I write a for statement and I say, for example, for integer I is equal 0, I less than 10, I plus plus, how many times this for loop is going to be executed? Exactly. If I said less than 20, it will be 20. Right? Then, if I say less than n, it will be n. So in this case, the for loop is going to take n time. It's going to be executed n times. So after going through the lines one by one, we can come up with an equation which can actually give us an overview about the overall performance. And usually the performance is the highest complexity, has the highest complexity. So for example, if the code has 10 lines, 5 lines are constant, which takes only constant C1. 4 lines takes n, and one line take n square. So the complexity of the whole algorithm is n square plus n plus 1. In total is n square. We will take the highest. Why? Because we are considering the worst case. No, we don't consider n to the power 3, n square, n to the power 2 يعني. Rawan. So, why we are considering this? Because we are considering the worst case. So, if you remember, each algorithm has a complexity starting from 1, and then we have n, and we have n log n, صح? And then we have square root of n, and we have the n square, and so on, until we reach 2n, 2 to the power n. So, after finding the complexity of the code, let's say that the complexity of the code was, let me find the color, okay, here, O n log n. Okay? This is the big O notation. So the code has a complexity n log n. This is big O notation. So this is actually, let me just give you here one example, change the color. So here, from this point, this is the n log n, including this group. This is called the upper bound. This is the upper bound. So the complexity of the code n log n, starting from n log n onward, this is called the upper bound. Okay, where is the lower bound? Starting from n log n, from n log n back to 1 and n, this is called the lower bar. So here we have upper, so here we have lower, and here is what? Average. Exactly. So for this algorithm, which has O n log n, O notation, big O notation is O n log n, the omega, the big omega of the code is what? No. Omega is the lower. Omega is the lower. No, it will be, as Safa said, n. It will be n. And the theta is the average. N log n, yes. N log n. Yes. This is just a general example. It not might be very accurate. I just want to show you what's the difference between the omega, theta, and the big O notation. So if, let's say, for example, you have a code, a Python code, or whatever language, and you have a print statement, like hello algorithm. This is going to be executed one time only. So this function is gn equal 1. So it's a constant, see? It's a constant function. This is when we have linear. So the gn is taking n time, is going to be executed n times. See, for I in range O to n, print I, so it's going to be executed n times. So every time we move forward, the n is growing linearly. No, this is 0, 0, yes. 0. Well, what do you mean by the override, Abdullah? I did not get your question, Abdullah. What do you mean by the override? No, riding, this is the override. We have a function call. So it depends on this function, how many times it's going to be executed. Yes, override is the same, yes. Same method. And same signature. Type. So this is how the execution estimation of the execution of this function. And then if we have another function here, see, we have the power of 2, this is another function. We have while statement, while statement. So while a is greater than 1, it will go through this direction, right? Else it will go through this direction. So we have two directions. One of them only is going to be executed. That's why the while and the if statement are going always to take log n. Log n, not n, log n. Both of if statement and while are going to be executed log n. Why? Because if you have a code which takes two or will lead you to one of the directions, so it's going to take log n. And this is how the log is moving. See, until some points, the curve, actually the line is going to the curve, not going up like the linear. Here we have the n log n. Actually, it looks like the opposite. See, this is how it looks, the log n. The n log n will change the curve. It is more closer to the n. It's closer to the n. And when do we need, or when do we have the n log n? When do we have n log n? If you have while that is inside for loop. This is a while inside the for loop. So the for loop here is executed n times, and the while here is executed log n. So the total is n log n. You got it? How we calculate the numbers? We evaluate the performance. Excellent. Okay, in this function, we have two for loops. They are nested loops. So this one is going to take n, and this is another n. So the total will be n square, because this one is going to be repeated n by n. So it's n square. and this is actually the series which is actually used to prove the n square. Any question? Yes. No, actually, this is just an explanation on how we get the n square based on this series. Okay. Now, n to the power 3. See, here we have 3 for loops. 1, 2, and 3. 3 for loops. We are going to execute this code, which is inside 3 nested loops. So this one is going to be repeated n times. This is n by n, and this is n by n by n. Yes, Yasser? What's the problem? The print statement, you mean where? In this code? Yes, of course. This is actually the time, the n square, n to the power 3. It is actually the time going to be considered for this statement, for the print I multiplied by j. It's going to be repeated n by n by n. We don't consider only the for loop. We are considering the code inside the for loop, not only the for loop itself. You got it? طيب, let me give you this example. I will write it for you. ايش رايكم بالكود؟ What is the complexity of this code? لا فاطمة, we don't consider الconstant. يعني we don't write divided by 2 or multiply by 2. عبد الرحمن, this code, you can see the code even? This code. what I want you to write not only the general answer. I want you to write يعني how you find n square or n to the power 3, how you found it. طيب ممتاز. طيب wait when you go okay طيب see let me explain something. I think there is something that you have not noticed, and that's why I write this example. See the second loop. The second loop is for j in range 0 n divided by 2. What does this mean? Means what? It doesn't matter. أيوة, half of n. Yes, Sonia. No, Rawan, that's not correct. It's not always n. That's why I write this example. It's not always n. For loop is not always n. I will provide you after the class. I will provide you with another set of examples which clearly show you, especially those who have covered the M180. They are very aware. They're supposed to be very aware of this issue, if they do remember it. Aywa, not all for loops takes n. Remember this. See here, n in the second for loop, it's going through all the numbers in up to n divided by 2, means half of the list. It's only half of the list. So which means the second for loop will take only log n. And here, the first one will be considered as n. So the total for print I is going to be n log n. So be careful while analyzing the algorithms. For loop are not always n. I know it was like very easy for you. Everybody is going, are answering the questions easily. But I have to highlight this one because I know that some of you are not aware that it's not always n for loops and loops in general. Why, Lama? Why? What's the problem? Why you get confused? No, I did not remove the n. I said that we haven't go through all values of n. Only half of them. Okay, do you remember the if statement? What did I say for the if statement? What is the complexity of if statement? The if statement, sorry. Aywa, it's if else. So only one of the direction. That's why in while loop, let's go back to the while loop. See here. See. See, in while loop, we did not consider it as n, even though while is a loop. but we consider only n, log n, because either one of the lines is going to be executed, the second one is no. So here is another form of what? Of division. We are dividing the code into two halves. Exactly. Yes, Rawan. Yes. Okay, excellent. Okay, this code. Why this code is 2 to the power n? If n equals 0, we return 0. If n equal 1, return 1. Else return fn minus 1 plus fn minus 2. Why do you think this code is going to take 2 to the power n? It looks very complicated. Here we have 1, 1, 1, 1, and here we don't know what's happening. Suddenly we have 2 to the power n. Why? What's wrong with this statement which make the performance takes 2 to the power n, or the complexity? What is this? No. 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 أيوة. Safa. أيوة. So what kind of calling the function? Yes. But which function we are calling here? No. Yes. Okay, calling the function f, right? Same function. So what we call this process? When the function call itself, we call it what? Exactly, Abdul Hakim. Recursion. This is a recursive function. Recursive function take 2 to the power n. Take 2 to the power n. Yes, when the function call itself, it's 2 to the power n. So if you want to sort the algorithm from the best in terms of complexity into the worst, that is the from up to bottom. This is the best when we have only constant. Then we have the log n, n log n, n square, n to the power 3 cubic, and exponential. Now I want you to know another fact. If, let's say, we found a function, the complexity of the function is O n log n, okay? Can we say that the complexity of the same function is O n square? Can we say this? Yani after we analyze one algorithm, we found that it is O n log n. Can we say it's O n square? Please give me 2 minutes. I'll answer the call until you find the answer.